Hey, what's going on, guys? KIM-1 here. In this video we're going to be compiling and running my 6502 chess program using the CC65 compiler patched by Dave Plummer, who is the retired operating system engineer from Microsoft from 90s. So he made a video where he has created a target platform for KIM-1 within the CC65 compiler. I've been covering that in the previous couple of videos, showcasing how to run the simple hello world and the prime number calculator. So the difference between those is that the hello world runs at starting from memory location 200 hexadecimal, assuming that's the unexpanded KIM, and the prime numbers were running in the target so-called KIM-1 60K, which stands for expanded KIM, with an additional, I guess, 60K of RAM. And the program there starts in that version, in that target platform, the program starts at 2000 hexadecimal. So just a little bit of a repetition from this in regards to the steps I've taken in the previous video. I've been taking the previous video. So here is the source code. So where you can get the compiler. Obviously I'm doing this on Linux, so I'm not sure how exactly this can be done on Windows, but as far as I'm going to be providing the executable that is going to be running here, you don't really need to follow through this. But for those interested how to compile for KIM-1 with this emulator, this might be quite interesting insight. So here, if we go to commits by Dave, and make sure to go to the branch KIM-1, and here this one, fix overflow, capitalization, and here just to download zip. So this doesn't work for some reason. It's just downloading the zip, right? And then you'll need to compile this. Compiling is very simple. So just to give a very quick idea, so here is the folder. Here is the make file. You just open the terminal, type make, and it compiles. It's very simple. No settings, nothing, just type make and you're done. And after this you have the samples folder, KIM-1, and the basic examples. So now I'm exactly in this folder. So if we have a look at the make file, well, originally there were only these two, like KIM-C, which is the prime number calculator, and the KIM-hello. I've added here chess bin, and I've duplicated the line for compilation, like for single file compilation from this KIM-C, to make sure that the target is 60K, with the various optimizations available there as well. So also I have added somewhere, yeah, the execute list, this bin, added this bin in order to actually build the source code. So here is the modified source code. So I've added the user interaction logic here in main. Now it's quite huge, but it allows to it actually allows to type moves by hands, echoing everything to the screen, because by default KIM-1 doesn't echo anything. So I'll now demonstrate how this is going to be working. It gives me a couple of warnings in regards to this specific lines of code where I'm asking whether to promote the pawn to queen or not. And I've been testing this logic and it works like a charm. So I have no idea what exactly where exactly the warning is coming from. So since it doesn't really affect the runtime, I just ignore that. So here, in order to make let me just kill the previous build. Okay, and get rid of this one. Okay, and don't save. Yeah, so make, and in order to make, I do the following thing. So make chess.bin, and then I'm opening that binary executable using the xxd with a -y with a -I option to and redirecting the standard output to the file to get. So this is the binary executable. We don't need this, so we need this one. So here are our bytes in hexadecimal format. It's made in the style of the C include file. So we now need to modify this a little bit. So just get rid of this here, so that we have the bare bytes. And now I'll going back, And now I just can copy this. So you see that these are just the raw bytes, right? Nothing special really. So now I'm going to my emulator. Here I have the converter, right? And I need to paste to the left, and here hex to DCB this button. So I've added another kind of option to my converter. And now here this DCB stands for like declare byte thing. So this is already can be assembled directly within the built-in assembler of this emulator. So now just click assemble. Now important the starting address. So this should be 0x2000 because this version is compiled for 60K expanded version. Here now upload, and now notice that it's 5K, almost 5.5K. So it's my original version without that fancy user redirection, but that was played only on a keypad that I made from scratch in assembly. That was only 909 bytes. So using this compiler, well, even though I did add a lot of code, but anyway, it's still kind of like more than twice bigger. So yeah, the benefit is you can easily and freely and quite fast write the code, compile and run. The downside is the usage of the memory. So it's, if you want to write something interesting like a chess program for an unexpanded version, then using this compiler is not all in the cards because you're just going to be running out of memory. Well, when I did this in the pure 6502 assembly, this worked, and that has been covered in the entire series here on YouTube, how I've been developing this exact version of chess, but directly in 6502 assembly. But this time we're interested in actually like compiling this. And here is the here are the bytes. So we just now we just uploaded the bytes. I'm going to 2000 hexadecimal and Shift G to run. And here we go. We got the 6502 chess by KIM-1. So far so good. In order to input the move, I just say E2E, and once I press 4, it actually makes the move and prints the board. Now I made it asking the user for a search depth every time because, well, this might be a little bit annoying, but if you want the program to see at least the maiden one, you need to have at least the depth of 3, and that would be take quite a bit of time. But if you want to be playing at the depth 3 in the complicated middle game position, it would be taken for around half an hour for an engine to make a move, because the performance of the emulator is near like in the original KIM, like the original 6502 as well. I can't say that it's 100% accurate, but it's really close, because when we've been testing this on real hardware, the results were quite similar. Right, so enter the search depth. So I recommend the depth 2 for a gameplay, and when it's coming closer to the end game, when you really want to ensure the engine can see the maiden one and actually checkmate you, in that case it's a good idea to switch depth to 3. So for now, just press 2, and it thinks for a while, and now it should make a move. Okay, it makes a move. So it's like it takes quite a bit of time, so it's not really instant. So you don't need to press enter or anything. Just press in like 2, and that's it. And it brings the depth is 2. This is the score and the best move made by the engine, E7 to E5. So now let's go, for instance, like what to play here. Let's see, G1 to F3. Well, let's go for this. So G1 goes to F3. All right. And let's go depth 2 again. So yeah, it's quite slow. It's actually interesting whether it's as slow as it's probably around as slow as it was like when I've been testing this with the original assembly version. So he plays D5. Well, it's a little bit strange move to say the least, because this actually, well, actually it doesn't really leave this pawn on, but yeah, so let's say E4 takes on D5, E4 takes on D5. Okay, so E4 takes on D5, and 2 for depth too. So yeah, literally the same ugly, slow program, but now with a bit improved user interface, so it's at least it's possible to play it now. Okay, queen takes. Well, I'm not going to be playing chess now because I've been demonstrating how what this engine is capable of by playing the entire game on a keypad with only the 6-7 segment LEDs to display the best move, and without even seeing the board. That would be fun to watch if you're interested. So, but yeah, actually, the concept has been just proved that we can compile it. So we can write an engine and see we can compile it, and we can run it on KIM-1, assuming that this is a expanded version, like with a 60K expansion. And yeah, by the way, the previous video, I made an expansion to my emulator, so it didn't have that memory from 2000 hexadecimal and up to FFFA. Now it does. So now we can run the software that is relying on that memory locations as well. This is it from my side, guys. Thanks for watching. Until the next time, and take care.